Assalamualaikum warahmatullahi wabarakatuh. We are from Group 3 and today we would like to present about Lab 3, Friction, Losses in Pipe.
Assalamualaikum and good day. My name is Siti Rana binti Abdul Rahim, Metro ID MA 18240. So I will continue our presentation on the theory of friction loss in pipes. So when a gas or a liquid flows through a pipe, the flow of fluid through a pipe is resisted by viscous shear stresses within the fluid and the turbulence that occurs along the internal pipe wall. Due to this, there will be a loss of pressure in the fluid because energy is required to overcome the viscous and frictional forces exerted by the walls of the pipe on the moving fluid. In addition to the energy loss due to frictional forces, there will be a loss in energy when the fluid flows through fittings such as valves, elbows, contractions, and expansions. This loss in pressure is mainly due to the local flow separation as it moves through such fittings. The pressure loss in pipe flows is commonly referred to as head loss. The frictional losses are mainly caused in a straight pipe. Friction loss induced in fittings such as bands, couplings, valves, or transitions in hose or pipe accounts for minor losses. The frictional losses are referred to as major losses, HL major, while losses through fittings are called minor losses, HL minor. Together, they make up the total head losses, HL, for pipe flows. Here are the formulas that are used to acquire head losses in pipes. So the first one is major losses, which is equals to HF. HF equals to F, which F is the Darcy-Weisbach friction factor multiplied by LV squared, where L is the length of pipe, V is the mean velocity of flow in the pipe, divided by 2 times D times G, where D is the diameter of pipe and G is the gravitational acceleration. And then we have minor losses, which is equals to HL minor, equals to K, where K is a dimensionless loss coefficient, which is obtained experimentally, and K is multiplied by V squared over 2G. And lastly is the total head loss, HL, which is equals to HL major or HF, which is added by HL minor. The friction loss in a uniform straight sections of pipe, known as major loss, is caused by the effects of viscosity, the movement of fluid molecules against each other or against the possible rough wall of the pipe. Therefore, to identify the type of flow, Reynolds number can be used to estimate if a fluid flow is laminar or turbulent. For laminar flow, the Reynolds number is below 2100, and tubular flow ranges between 2100 and 4000. Meanwhile, the RE for transitional flow, which is a mixture of laminar and turbulent flow, is above 4000. That's all from me. Thank you so much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Falsafi bin Abdul Aziz, MA 19021. Firstly, introduction. For the brief background, the experiment is about the limit of study to flow through and through around pipe and pipe fitting. And then the pipe will go through the elbow and the valve in the closed circuit of the pipe. Next, the objective is firstly to design complete measurement technique for fluid flow. Second is to determine major and minor losses in different piping system, and lastly to investigate the velocity for different diameter of pipe. Next, the problem statement is firstly the viscosity of fluid, next the size of internal pipe diameter, and then the third is the type of pipe, and lastly the change in elevation between the end of the pipe and the length of the pipe along which the fluid travel. Last but not least is about the scope. The scope of the experiment is involved the determining of the head loss coefficient based on any viscous fluid that flow through the pipe and the loss pressure due to the friction. And there is also the major loss due to viscous effect in straight pipe and the minor loss due to viscous effect in the pipe component by using the 4 types of the pipe that be used in this experiment, such as the straight pipe, elbow pipe, and 90-degree bend pipe and 45-degree bend pipe. And then we will plot the head loss for our velocity, friction coefficient over Reynolds in order to identify the value measured. Thank you very much.
Assalamualaikum and very good morning to madam and friends. Today I want to present about the chapter 3, method and procedure. 3.1, apparatus and material. I want to show the figure first. One is in the figure 3.1, 1.1 is fluid friction apparatus. This is a fluid friction apparatus. And then second, figure 3.1.2, this is a hydraulic page. And then third picture, this is a figure 3.1.3. This is a pressure sensor. And then lastly, figure 3.1.2, this is a data measurement and data acquisition. And then 3.1 experiment procedure. First, by turning the valve tab to the left or the fluid friction device valve is open. When all of the valves are turned on, power supply and the pump can be switched on. Second, control valve is used and water valve adjustment adjusted. Then the unused valve will be closed for the first experiment, that is the straight pipe. Third, following that, a pressure measurement inside the pipe was connected to two pressure sensors. And then a flow rate can be recorded within the pipe by the flow rate indicator. And then repetition, step 1 to step 4 for various pipe type, 90 degrees, 90 degrees and 45 degrees, beading, piping, and lastly, all the data tabulated and volumetric flow heat loss are recorded. That's all for me. Thank you.
Assalamualaikum and good day. My name is Hazika Naziha binti Muhammad Kamal Arifin at MA18277, and I will present about result and discussion for experimentary friction losses in pipe. We start with given data. The given data, which is L is 0.8 meter, internal diameter is 0.02 meter, and the pipe thickness is 0.0015 meter. And for the experiment 1, which is measureless losses, we should complete this table, which is we should calculate flow speed, Reynolds number, pipe friction coefficient, and calculated heat losses. And we use this formula and calculation. We use flow speed formula, Reynolds number formula, friction coefficient formula, and heat losses formula to complete all the and do the calculation and complete all the table that given. Then this is the result for the straight pipe, elbow pipe, 19 degree bend pipe, and 45 degree bend pipe. So for the experiment 2, which is minor losses, we should calculate loss coefficient, which is K, and equivalent length LE. And we use this formula and this formula to calculate to complete the table. This is the table for elbow pipe, 18 degree bend pipe, and 45 degree bend pipe. So this is the graph, straight pipe, which is head losses against velocity, and coefficient friction against Reynolds number. For the elbow pipe, and graph for 90 degree bend pipe, and graph for 45 degree bend pipe. That's all from me. Thank you.
My name is Muhammad Faris bin Azlin Shah, ID MM19033. As for conclusion, throughout the experiment values for major and minor head losses are calculated and they are compared to theoretical values respectively. Major head loss is caused by frictional force in the straight pipe and minor head loss is caused by the loss coefficient of various pipes fitting. It shows that as the mean velocity of the fluid increase, the head loss increase. Moreover, the value of the mass flow increase. It is noticed that the value of the head loss increase as Reynolds number increase. This is due to the value of Reynolds number relying on the mean velocity of flowing fluid. The inconsistency of the result is caused by some factors such as human and environment.